Alright, Bismillahirrahmanirrahim. So today we are just going to be talk about the prime product of prime, or in other words, you have to be talk about the prime factorization. A prime factorization is basically a process in which we are going to be breaking down the composite numbers. We know that the prime numbers are the numbers they are divisible by itself and one. They have two divisors, and rest of all the numbers are going to be a prime numbers. For example, if I'm going to be write the set of the prime number here, we have prime numbers are going to be started from 2, 3, 5, 7. 8 is not a prime number, 9 is not a prime number. Then you have 11, 13, 17, and so on. In the second last class, I had to write the prime numbers all from 0 to 100. So all the rest of the numbers are known as composite numbers. So the composite numbers are 1, 2, 3 are prime numbers, so 4 is a composite number. 5 is a prime number, so 6 is a composite number. 7 is a prime number, so 8, 9, and 10 are the composite numbers. 11 is a prime number, 12 is a composite number, then 14, 15, 16, 17 is a prime number, 18, and so on. So all the numbers that are divisible by itself and 1, they are prime numbers. So then the numbers that are not divisible by they are divisible by more than two numbers, so they are known as composite numbers. So we are going to be breaking down the composite numbers into the form of prime factors. For example, examiner is going to be give you a one question. He says that you have 729, and he says that you have to find the prime factor. And all right, let's we have to find that 729 is going to be a prime number or not. So what we will do, we just are going to be, we have two different ways. We have to find the prime factors by this way. We have 729. We have to be look for the 729 is going to be divisible by on a smallest prime number. So the smallest prime number is 2. So 729 is not divisible by 2. So you have to go for the next prime number, that is 3. So we have 3 times 2 is 6, 3 times 4 is 12, 3 times 3 is 9. Now again they are divisible by 3. 3 times 8 is 24, 3 times 1 is 3. 3 times 2 is 6, 3 times 7 is 21. 3 times 9 is 27, 3 times 3 is 9, and 3 times 1 is 3. So we are going to get all the prime factors of 729 will be equal to, we have 1, 2, 3, 4, 5, 6. So you will get 3 raised to power 6. Yes, everyone. Any question till here?
No, sir.
No, sir.
All right. Look at here. He's going to be give you the number 36, and he says that you have to find 36 as the product of its prime factors. So again, we have to divide by 36. It is divisible by 2. 2 times 1 is 2. 2 times 8 is 16. 2 times 9 is 18. 3 times 3 is 9. And 3 times 1 is 3. So we have to get the
Sir,
prime factors. Yes.
this is LCM, yes, to find
No.
lowest common multiple.
No. LCM basically is the least common multiple between two or more than two numbers. Okay. Here we are
Okay,
finding the prime factor. It's a single number. You are just finding the prime factors of this one. Means
got it,
if you will multiply these numbers, you will get 36.
got it.
prime factors of 36 will be equal to 2 square times 3 square. So the prime factors of 36 is 2 square times 3 square. Okay, we have another way to find the prime factors of 36 that, for example, if you have a 36, so let's we have to make a T diagram. So 36 is divisible by 2. So 2 times 18 is 36. Now again, 18 is divisible by 2. So 2 times 9 is 18. Now again, 9 is divisible by 3. So 3 times 3 is 18. So basically here you are going to get all the prime factors of 36. This is another way that you are going to make a T diagram. Sometimes examiner give you the T diagram or he's going to be ask you that you have to draw the T diagram of for the prime factors of 36. Right? So this is how you have to make it. It's up to you. You have to find the prime factors by this way, or you have to find the prime factors by making a T diagram. For example, look at here, we have 100. So let's we have to make a T diagram of prime factors T diagram of 100. So we have 100. So I know that the 100 is divisible by 2. So 2 times 50 is 100. Now again 50 is divisible by 2. So 2 times 25 is 50. Now 25 is not divisible by 2. So go for next prime number, that is 3. So it is not divisible by 3. So go for next prime number. So that will be 5. So 5 times 5 is 25. So we are going to be get the prime factors of 100 will be equal to 2 square times 5 square. Yes, I want. Any question?
No,
No,
sir.
sir.
Right. Now we have a next question. He says that write 42 as a product of its prime factors. So again, you have two different ways. Here we have to find it by making a T diagram. Let's do it by this way. You have to do it by dividing the 42. All right, now we have 42. 2 times 2 is 4, 2 times 1 is 2, 3 times 7 is 21, and 7 times 1 is 7. So we are going to get the prime factors of 42 is equal to 2 times 3 times 7. So these are the prime factors. Prime factor means you have to be write the composite number 42 in terms of their prime factors. Obviously, every composite number is going to be made up or make up with the product of the prime numbers. All right, next we have right at 24 as a product of prime number. So let's do it by the T diagram. We have 24. So 24 is divisible by 2. So 2
Sir,
times, yes.
what do you mean by index form?
Index form means in the power form, like this. We are already writing in the power form or index form.
Okay, got it.
Okay. Now you have 2 times 6 is 12. So 2 times 3 is 6. So we are going to get the prime factors of 24 will be equal to, we can write it as 2 times 2 times 2 times 3. So it's a prime product of prime factors. But he says that you have to write into the index form. So you have to, this is the same, we have to add the powers. We have 3 2's, the 2 raised to power 3 times 3. So now we have to write this one into the index form. Yes, everyone. Any question till here?
Yes, sir.
What is the question? You mean no question, right?
Yes, sir.
All right. All right. Please do this question on your notebook and send me the working. Do it by the both methods. You have to be so you do it by the T diagram. Find the prime factors of this number by using a T diagram.
So can you just show one of the tree diagrams for an example?
All right.
Okay, got it.
All right. I see the picture. Yeah, that's it. Yes, everyone. You have any question about the prime factors?
No, sir.
No, sir.
All right. Now let's we have to talk about the factors and multiples. Factors and multiples. Yes, anyone. What does it mean by factor?
Sir, numbers which come in a table of a number. Like 10
And
is a like 5 is a factor of 10.
5 is a factor of 10, okay. Yes, Azizu, you have any idea?
No, sir.
He's right. A factor is basically a factor of a number, a factor of a number is any number, means you are, he's going to give you the example of 10 and 5. So any number that divides into it exactly. Exactly means with no remainder. So we can say that it is going to be a factor. For example, if you have a number 8, factors of 8. So look at here, 8 is exactly divisible by 1. So 1 is the factor of 8. 8 is exactly divisible by 2. 2 times 4 is 8. So 2 is the factor of 8. 8 is not divisible by 3. So 3 is not the factor of 8. Alright, next we have 5. 8 is not divisible by 5. 6 not divisible by 7. It is divisible by 4. And then it is going to be divisible by 8. So 1, 2, 4, 8 are those numbers in which 8 is exactly divisible. So we have to say that these are the factors of a number. All right. So any number that divides into it exactly, so these numbers are known as the factor of the numbers. Yes, everyone. Any question?
No,
No,
sir.
sir.
Okay. The next thing is about the multiples. Most of the students are going to mix up the multiples and the factors. Basically, multiple is the product of that number. Okay, means you have to give any number. So all the multiples of that product of that numbers are basically known as the multiple of that numbers. Like if we are going to be talking about the multiples of 8. So look at here, 8 multiplied by 1 will be 8. 8 multiplied by 2 will be 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48, and so on. So the all the numbers you have to the product of any number with it, they are known as going to be the multiple of that number. That's the difference. Look at here. If we are going to be talk about the factors are going to be limited. Means you have two factors of a number, five factors of a number, 10 factors of a number. On the other hand, if we are going to be talk about the multiples, so multiples are infinite. You have to multiply by 8 with 100, 8 with 200, 8 with 1000, 8 is 1 with multiply by 1 million. Obviously, you will get a number, so that number is also the multiple of 8. So factors are going to be a limited one. They are finite numbers. On the other hand, if you are going to talk about the multiples, so they are limited. Yes, everyone. Any question till here?
So,
No, sir.
The difference between the factors and multiples is clear.
Yes, sir.
yes.
Okay, let's we have to find some factors of more numbers. Let's we are going to be talk about the factor of 12. The factors of 12 are going to be it is divisible by 1, divisible by 2, divisible by 3, divisible by 4. Yes, Mehran.
Sir, do we include 1 as the factor of a number?
Yes, 1 is the factor of all numbers.
Okay, sir.
4, 5, 1, 12 is divisible by 6 and it is divisible by 12. In the same way, for example, if I'm going to be talking about the multiple of 12, so we have it will be 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. It will be 60, and there will be so on. All right. Let's take any other number. We have to find the factors of that number. The factors of, let's say we have to find the factors of 6. The factors of 6 we are going to be get. It will be 1, it will be 2, it will be 3, and it will be 6 itself. In the same way, we are going to talk about the multiple of 6. It will be 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 24, 30, 36, 42, 48, and so on. Okay, why I'm going to be write all of these numbers? Okay, factors and multiples are going to be clear. Now we have a next concept that is about going to be a HCF and LCF. Yes, HCF stands for
Sir, high common factor.
highest common factor of the numbers. On the other side, if we are going to talk about the LCM is basically
Lowest.
the lowest or least common multiple. It's a multiple. Now, for example, if I'm going to be talk about the HCF of 8 and 12, we are talking about the HCF of 8 and 12. So yes, tell me which is the highest. Look at here. If we are going to talk about the 2 is the common factor between both of them. 4 is the common factor between both of them.
Highest common factor is
So
4.
yes, the highest common factor if we are going to talk about that is going to be 4. Okay. In the same way, for example, if I'm going to talk about the HCF of 8 and 6. So in 8 and 6, obviously 1 is going to be a common factor, 2 is going to be a common factor, and that's it. So which is the highest common factor between these two numbers?
2.
That is 2. In the same way, we are going to talk about the HCF between 6 and 12. So let's say is it. So look at here. 1 is going to be the common factor, 2 is common factor, 3 is common factor as well, 6 is going to be common factor as well. But we are looking for the HCF, the highest common factor. So which is the highest common factor between 12 and 6?
Oh, sir, 6.
That would be because the highest common factor between both of them, 1 is the common factor, 2 is also the common factor, 3 is also the common factor, 6 is the common factor. But in all of them, the highest one is 6. In the same way, for example, if we are going to be talking about the HCF of all of these three numbers, if we are going to be talking about the HCF of 8, 12, and 6. So look at here in all of them, 1 is the common factor, we have 2 is the common factor, and that's it. There is nothing, there is no number. We have 6, but in these two of them, we have 4 in these one of them, we have 3 in these of them. So the highest common factor in this one is going to be 2. So when you are going to be finding the HCF, basically in HCF you are finding the highest common factor. You have to write all the common factors and just take a highest one. So that is your HCF. Yes, everyone. Any question?
No, sir.
Okay, let's we have to talk about the least common multiple. We are talking about LCM of 8 and 12. So look at here, we have 24 is the least common multiple. We have 48 is going to be a common multiple. If we have moved further, obviously we have more multiples as well. But we are looking for the least common multiple. So in all of them, we have the least common multiple is going to be 24. We are looking for the smallest common multiple. So the smallest common multiple or least common multiple is going to be 24 between 8 and 12. In the same way, for example, if you are going to be looking for the LCM of 8 and 6, so in 8 and 6, so look at here, we have
24.
24, then we have 48. In this one, you are going to be getting 24 as well. By chance, we are getting same. Both of them, we are going to be getting 24. Okay, next we are going to be talking about the LCM of 6 and 12. So look at here, we have the common multiple that is going to be 12. 24 is also the common multiple. 36 is going to be also the common multiple. We have 48 is also the common multiple. And obviously next we have 60 is also the common multiple. So, but we are going to be looking for the least common multiple. Yes, what is the least common multiple here?
12.
That is going to be 12. All of them are the common multiples, but we have to look for the lowest common multiple. If you have to look at carefully, we have numbers and we are going to be get the factors. The factor is always lesser than or maximum it is going to be equal to one number. Okay. But if you are going to be talk about the LCM, the LCM is mostly is going to be a bigger number or it is going to be maximum to equal to the bigger number. All right. It means the LCM can never be lesser than of this number. If you have 12, so the bigger number is 12, so the LCM of two numbers can never be lesser than 12. In the same way, we are going to be talking about the LCM of 8, 12, and 6. So we have 24, then we have 48, and obviously we have some more. So in the smallest one in this case, we have 24. So in the LCM, we have to take the lowest common multiple, and in SCF, we have to take the highest common factor. Yes, any of you having a difficulty about to understand that what does it mean by the LCM and ICF? What does it mean by the factors, the difference between the factor and multiple? Yes.
No, sir.
Okay, this is one of the way that you have to find the LCM and ICF. Okay, you have to write, if you are finding the ICF, so write all the factors of that number, and then you have to choose the highest common factor. In the same way, if you are finding the LCM, so write all the least common multiples of that, the multiples of that number, and then you have to take the lowest common multiple. This is one of the way to find the LCM and ICF. But mostly we are not going to use this method. Okay, which method we have to use? Let's do the question. Yeah. Now look at here. He says that you have find the highest common factor of 48 and 56. You have to find the highest common factor. We have different ways. The one of the easiest way we have to use it by dividing of both numbers. Let's see how to divide it. We have 48 and we have 56. Okay, in SCF you have to divide the number when the both numbers are divisible. Okay, if one of them is divisible, you will not divide it. You have to divide on which number when both are divisible. Smallest prime number is 2, so both of them are divisible by 2, so let's divide it. 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4, 2 times 8 is 16. Now again 24 and 28, both of them are divisible by 2, so let's divide it. 2 times 1 is 2, 2 times 2 is 4, 2 times 1 is 2, 2 times 4 is 8. Now again both are divisible by 2, 2 times 6 is 12 and 2 times 7 is 14. Yes, now both are divisible on any same number,
No.
No, sir.
so we will not divide further. So we will get the HCF of 48 and 56 will be equal to 2 times 2 times 2. That would be 8. Clear? In the HCF, you have to divide till when the both numbers are going to be divisible by on the same number. And for example, for the same number, you need to find the LCM as well. If examiner says that, you have to find LCM of 48 and 56. So we have to use the same method. We will divide them, but we will divide if the numbers are divisible by, you will get 1 1 till end. We have 48 and 56. We just have to divide it on the prime numbers. Both any number is divisible by 2, so 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4, 2 times 8 is 16, 2 times 12, 2 times 14, 2 times 6, 2 times 7. One number is still divisible by 2, so divide by them. 2 times 3 is 6, 7 as it is. Now both of them are not divisible by 2, so go for the next prime number, that is 3. So 3 times 1 is 3, 7 as it is. Now 7 is divisible, 7 times 1 is 7. Now we are going to be get the LCM of 48 and 56 will be equal to 2 raised to the power 4 times 3 times 7. 2 raised to the power 4 is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is
16.
16, and 3 times 7 is 21. Yes, please multiply them. What you will get?
Sir, 336.
336. So 336 is the LCM of 48 and 56. So look at here. What is the difference between the method of both of them? If you are finding the HCF, you will divide till when the both numbers are divisible. Okay. And in LCM, you have to divide till the both of numbers are become 1 1. Yes, everyone, it is clear?
So could we just copy down the example?
Yes, yes. This is the one of the method. We will do one more question. And inshallah, in the next class, we have to do another method. And that is basically the main method in which we have to find the LCM and HCF of the number by using the prime factorization method. Right now, we are just going to be learn the methods, okay? And obviously, we will do some practical examples of this one as well.
Sir, done.
Yes, so this you have done as well.
Yes, sir.
Right. Look at here. The questions that I'm just going to be skip them, you have to do it by yourself, okay? Now look at here, he says that you have to find the LCM of 60 and 75. So the method that you have learned that what it is, you just have to divide them. Let's divide it. We have 60 and 75. We have 60 and 75. 2 times 3 is 6, 0. 75 is not divisible. 2 times 15 is 30. 75 is not divisible. Now both of them are not divisible by 2, so we have to go for the next prime number, that is 3. 3 times 5 is 15, 3 times 2 is 6, 3 times 5 is 15. Now both are divisible by 5, 5 times 1 is 5, 5 times 5 is 25. So 5 times 1 is 5. So I'm going to get the LCM of 60 and 75 will be equal to 2 squared into 3 into 5 squared. 2 squared will be 4. 25 is 5 squared will become 25. 4 multiplied by 25 will be 100. 100 multiplied by 3 will be 300. So we will get the LCM of 60 and 75 will be 300. Yes, everyone. Any question?
No, sir.
All right. Inshallah, in the next class,